All right, welcome back. We're going to do a little bit more statistics, and it takes a little bit of time to understand this stuff. So don't sweat it if you get it when you watch the video, but then when you come back to it, you're like, wait, what was that? And the main thing here is to develop familiarity with statistics, and you're doing that by reading the textbook, by watching these lectures, by doing some assignments, and you're gaining that familiarity. And so by gaining that familiarity, you're becoming familiar with statistics and working with data and making sense of data and different data sets and gaining more insights into it, right? So we're gaining insight and familiarity into how we work with data and data sets and what inferential statistics are when you have a sample to make inferences about a population, and what descriptive statistics are. So when you have visual representations of the data like we saw at that gapminder.org website, or like we saw when we did histograms or dot plots in chapter 2, module 2, or when we have numeric measures which serve as descriptive statistics, like we've been looking at in this module. We've been looking at numeric measures which serve as descriptive statistics. They give us insight into our data and our data set, and our goal here is just to become familiar with it. And this familiarity will allow us, if we ever proceed forward with statistics, it's like we've spent a little time in this domain, and by having spent a little bit of time in this domain, if we move forward with it in our job or in additional classes, then we're going to be able to deepen that knowledge. And by using this information, it's like learning a new language. By using it, you're going to become more conversant in it. And so some of this stuff, it might make total sense when you read it, or when you do the assignment, or when you watch these videos. But then when you come back and you look at it again, you'll be like, I remember it made sense when I was going through the video, and I'm looking at it again. I'm not quite as conversant, not quite as fluent with it. That's totally normal and natural. Don't stress it, don't sweat it. Right? The main thing is to gain familiarity, and then if you go deeper with it at work, or if you go deeper with it like by taking additional classes related to it for some reason, you'll gain more fluency and you'll gain more skills by using it on a regular basis. So it's like that with a lot of things in life. You can learn stuff, you can kind of understand it, but then if you come back to it, it's like, oh yeah, how do I do that jump shot? Or oh yeah, how do I do that computer programming thing? It's only by using something day in and day out that you truly master it. And the main goal here is just to develop that familiarity, through the reading, through the lectures, and then also through doing assignments. And by gaining that familiarity, you're building a little bit of a little bit of exposure to it. So if you ever go deeper with it or need to call back upon it, it'll come to you more easily. So that's my little pep talk on statistics, because it can be a little bit overwhelming. And when you look at all this stuff, you're like, I understood it when I saw it, but now I'm looking back at it and what's it mean? And really what we're looking at here is trying to understand our data and our data set. We're trying to use some sort of different ways to explain that, whether it's graphical descriptive statistics or numeric descriptive statistics. That's what we're doing. And so our numeric descriptive statistics, we're using the mean here to sort of get an idea of central tendency. Like if we were shooting arrows at a target, where's like that center point, right? From all the arrows scattered around, where's that center point? And so that's the mean, or the average. It's that measure of central tendency. And we could also look at the median, and we could also, the median is the median in the road. It's the middle of the road. It's also the median in data is the middle of the data. So the median here would be 10. It's the middle of the data. We have an odd number of data, and we'd sort that, and we'd look at it from left to right, and we'd find the one in the middle. And the median for the one in the middle, in this case, is 10, but if there happened to be an even number of data points in our data set, we would take the two that were in the middle, add them up, and divide by 2, and then that would be our median. So we could have done our median, and if we wanted to, we could just kind of explore that here. So I'm just going to like insert 2 more rows, and I'll insert those above. But our median in this data set would also be 10. Whoops, that's 20. Here's our median in the data set. And our median in this data set, right, if we rank it from 2, 3, 5, 10, and 30, 10 is also going to be our median in this data set. And then if we look at our data set here, we have 14, where's my mouse? Where's my mouse? Where's my mouse? There it is. we have 14, and then after 14 we have 15, and then 16, and 17, and 18. So 14 and 15 are the two on the left side if this was on a continuum. 16 is the next one, and 17 and 18 would be on the right. So 1675 would be our median there. And then if we were to look at our mode on all of these would be no mode, none, right? Because we don't have any data. Oh, actually here we have bimodal, and so our mode here would be 8 and 12, right? Those occur twice, and here is none. We have no mode there. And then over here we have no mode here because we don't have anything that occurs more than twice. And I'm just going to create a little divider here just to divide these sort of measures, which are really sort of measuring like that central tendency, and like, you know, what's that central tendency? How long does it take for the data? And they're measures of location, mean, median, mode. If we wanted to, we could calculate the percentiles and the quartiles. But then we also, not only is it important for us to kind of have these measures of location, like what are different kind of locations in our data, which could give us insights into the data, but also we want to see how does our data distributed, what's the variance, what's the dispersion. And so we use these down here for that. And we had that range, the difference between the high and the low data. And then we had variance. And so with variance, we were looking at how much does each data point, and we could click on this to see what is that formula. And we could see here we're taking D7, and D7 is we took each of these data points, and we subtracted it from the mean. And when we did that, we got -2, and then we squared it, and then we added all of those up, and we got 16, and then we divided by the number of elements which were in our data set less 1. And so that formula that we did that with is just a little bit of a review. That formula is right here. So the data point minus the mean, square it, add them all up. The data point minus the mean, -2, square it, 4, add them all up, 16, right? Get that 16, and then divide it by the number of elements in our sample, less 1. And then that gave us our variance right there. And then our standard deviation, since this is at like a squared scale, we squared everything right here, the difference, that took us up, right? It took us up by a multiplicative factor. It took us up. So to bring us back down, we take the square root. So we go from 4 to 2. And then just to normalize that between data sets with different scales. So these two data sets are like on the scale of days. This data set here is like on the scale of years. And to normalize that, you know, between data sets with different scales, we took our standard deviation, which is D15 right here, and we divided it by our mean. And when we do that, we get a percent. And then that kind of like allows us to be able to compare variation, coefficient of variation, allows us to be able to compare variation between different data sets with different scales. So whether it's days or whether it's more along the line of years, right? Bigger numbers over here, we can compare like what is the variation in a similar way when you compare it relative to the mean of that data set. So that's sort of like, I want to use the word normalize. It normalizes the data between different scales, data sets with different scales. But normalize is a word that's pretty loaded in statistics. So I'm using it just like in the casual colloquial way, or maybe in the programmatic way. And in statistics, normalizing stuff has a slightly different definition. Or you know, having data that's normal has a different definition. So maybe normalize is fine. So there's that's a little bit of an overview. And then the next thing we're going to do is we're going to see, like with each individual data point, we're going to see how far is that each individual data point in standard deviations, how far is it from the mean. And we're going to do that with the z-score. So we're going to see that in the next video. See you in the next video.